Lesson 3.6 is all about estimating square roots, and we've actually taken the square root of perfect squares from yesterday's assignment, and now we're going to estimate the square root of non-perfect squares. So here, for example, a couple wants to install a square stained glass window with wood trim. You can calculate the length of the trim now using your knowledge of squares and square roots. We know that the area of a square is side squared. If we know the area, we can take the square root and that will give us one length of the side to know how long one side of the trim should be, and then we would just multiply it by 4 so that we know all 4 sides of the trim. Recall from yesterday that a perfect square root is a number whose square roots are integers, or a perfect square, is a number whose square roots are integers. For example, 25 and 100 are perfect squares. The square root of 25 is 5, the square root of 100 is 10. But now, like I said before, we can use square roots of perfect squares to estimate the square roots of other numbers. For example, the square root of 30 is between two consecutive, and consecutive means one right after the other, integers. We need to name the integers. So it might help a lot if you get out that sheet that I had you make yesterday with a list of the perfect squares up through 20, so up to 400 basically. So square root of 30 is between the two perfect squares of 25 and 36. And then I know the square root of 25 is 5, and I know the square root of 36 is 6. So the square root of 30 is going to be between 5 and 6. Those are the two integers that it's between. Here's another example. While searching for a lost hiker, a helicopter covers a square area of 150 miles squared. So we're looking at a square area, so I know that the side squared is 150. What's the approximate length of each side of the square area? So I have to square root it. That's the inverse operation. And so I'm rounding this to the nearest mile, so I'm really looking again at the closest integer. So 150 is between the two perfect squares, 144 and 169. The square root of 144 is 12. The square root of 169 is 13. Now I can't say, okay, it's between 12 and 13 miles. I know it is. However, it says round your answer to the nearest mile. So I have to choose 12 or 13. So I ask myself, which one is 150 closer to? So 150 minus 144 is 6, and 169 minus the 150, or subtract the 150, is 19. So it's closer to 12 miles. It's closer to 12 miles. In some cases, they're going to actually have us approximate the square root to the nearest hundredth. So this does take a little bit more work on our part, but it's going to start out the same way. So step 1, we're going to find the value of the whole number. So I'll write down the square root of 200, and if I look at my table, I know that that's between the square root of 196 and the square root of 225. Square root of 196 is 14, and the square root of 225 is 15. Now I know that the square root of 200 is 14 point something. It cannot be 15 point something because it's smaller than 225 but bigger than 196. So my whole number is going to be the 14. So there's step 1. Step 2, I have to work on the decimal portion. So what I do is I take this 196 because that was the perfect square, and I'm going to take 200 and subtract 196. I'm finding the difference between 196 and my number in question, and that's 4. And then I take the larger number, the 225, and I again subtract the 196 because that comes from the whole number portion. So 225 subtract 196 gives me 29. So that's step 2. Step 3, I'm going to go ahead and figure out the decimal portion here. So I'm looking at the quotient of the differences. So 4 divided by 29 is approximately 0.134. Oops. but then I'll round that to 0.1. I don't know where I got 0.134. I'm looking, it should be 0.138, sorry. So make that 4 and 8. So I round that to a 0.14. In step 4, I write my final answer. So the whole number is 14, and the hundredth actually happens to be 14 hundredths. So the square root of 200 is approximately 14 and 14 hundredths. I think we should do a couple more of these. So let's look at the square root of 87. So the first step, I take the square root of 87, and I know that's between the perfect squares of 81 and 100. Square root of 81 is 9. Square root of 100 is 10. So I know it's going to be 9 point something. Step 2, I take the 87 and subtract the 81 because I'm working with this, and that's a 6. Then I take the 100 and I subtract the 81, and that gives me 19. So there was step 2. Step 3, I find the quotient of the differences. So 6 divided by 19. If you just remember, take the small number and divide by the big number, you're good. That's about 0.316. So step 4, well, I'll estimate that that's, or round it to 0.32. So step 4, I write my whole number and then the decimal estimation. So 9 and 32 hundredths is approximately what the square root of 87 is. Let's do one more of these. So square root of 319 is between the square root of 289 and the square root of 324. Again, this is where your table will come in very handy. Square root of 289 is 17. Square root of 324 is 18. I know I'm using the 17, so there's step 1. Step 2, I will go ahead now and take 319, subtract 289, and that gives me 30. And 324, subtract again the 289. 324 subtract 289 is 35. Step 3, I take the smaller difference divided by the larger one. So 30 divided by 35 is 0.857 approximately. So I would round that to 0.86. And step 4, my whole number is 17 and the decimal approximation is 86 hundredths. So the square root of 319 is approximately 17 and 86 hundredths. Okay, the last method for approximating square roots is probably going to be your favorite method. That's using the calculator. So you can use the scientific calculator that comes with your book or that's on the computer. If you're using the one that's on the computer, you just type in 700 and then the square root symbol is right here. So it says round to the nearest tenth. It's approximately 26.5. So that's probably the better way. I mean, not the better way, but the quickest way. If we look back at what we did before, square root of 87, if I type that in right here, 87 square root, 9.327. We ended up, I think, with 9.32, so it's very close to what we said. If I rounded this to the nearest tenth, it would be 9.3. And that's about what I got, 9.3. I got 9.32. Okay, so that's how you use the calculator. Here is your assignment for lesson 3.6, page 118 to 119, problem 17 to 51. I know it looks like an awful lot, however, these should not take you very long at all, especially if you use your table to help you out. This is lesson 3.5, squares and square roots. Let's think about the relationship between the area of a square and the length of the side. Now we've talked about this before. The area formula for a square is side times side. So for example, let's say that this square is 36 centimeters squared. So that means it would take 36 little centimeter squares to cover this particular square that I've drawn. If I know that the area is side times side, then I can actually write it as area equals side to the second power, or side squared. Remember, this is to the first power, and then you add the exponents. So I'm really asking myself, what number times itself gives me 36? And the answer is 6. So each side of this square would be 6. And what we actually did was we took the square root of 36, and that's what we're going to get into today. So again, the area is 36 square units. I made mine centimeters, and the side length is 6 centimeters in this case, because 6 squared is 36. So here's some definition work. A number that when you multiply it by itself to form a product is the square root of the product. So that's pretty wordy. What it means is if you take a number, 7 for example, really? Ooh, I can't control this. Let's try this again. If I take 7 squared, which is 7 times 7, that equals 49. And if I then square root 49, that equals 7. So a number, when you multiply it by itself, here's that product, and that number is the square root of that product. So 6 squared is 36, and the square root of 36 is 6. When you take the square root of a non-negative number, it's the inverse of squaring the number. Remember, it undoes the operation. Addition and subtraction are inverses. Multiplication, division are inverses. Squaring and square rooting are inverses. So if I have 8 squared, we know that equals 64, and the square root of 64 then equals 8. All right, every positive number has 2 square roots, one positive and one negative. Here's the radical symbol, and it indicates the non-negative or the positive principal square root. And then this symbol, negative square root, is used to indicate a negative square root. For example, I can have the square root of 81, and I would say that that's 9. If I write negative square root 81, then I want to make that answer negative 9. If they're asking for 2 square roots, and some of your directions will say that, if I have the square root of 25 and it asks for 2, then I can use this plus minus symbol right here. I know it's positive and negative 5. And this is the case because I know up here, let's backtrack a little, 9 squared is positive 81, but also negative 9 squared is positive 81. So it does work that we get 2. Let's jump down to this little cautionary box down here. The square root of negative 49 is not the same as the negative square root of 49. You cannot take the square root of a negative number, because there is no number that when you multiply it by itself that'll come out to be a negative. Any number times itself will be a positive. These numbers right here, 16, 36, 49, etc., are examples of perfect squares. So a perfect square is a number that has integers as its square roots. So for example, 1 is a perfect square because the square root is 1. 4 is a perfect square because the square root is 2. 9, the perfect square, its square root is 3, etc. What we're going to do on the next page is make a table of perfect squares. So I want you to write this down. You've got your perfect squares. And once I'm done making this table, I suggest you pause the video and write this down. It's very important. So I know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. Notice all we're doing is reversing the last two digits. That's kind of cool. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. So all of these numbers to the right are the perfect squares. And the numbers to the left are their square root. And by to the left, I mean the 1, the 2, the 3, the 4, etc. Not the 4 squared, but the square root is actually the 4. Alright, let's do a few examples. Here they're asking us to find the two square roots of each number. So 64 is just positive and negative 8. 121 is positive and negative 11. 25 is positive and negative 5. And 144 is positive and negative 12. Piece of cake. If you need to use your table for some of the larger numbers, go ahead, but try to memorize them. It's going to make it a lot quicker. Okay, simplifying each expression. The first thing we're going to do is the addition that's underneath this radical sign. So 32 plus 17 is 49, and the square root of 49 is 7. They're not asking for two square roots. They're just asking us to simplify this. So we're just going to make it 7. Square root of 73 minus 48 is going to be the square root of 25. And we know that that answer is 5. Here I have 2 times the square root of 64 plus 10. So the first thing I have to do is take the square root. Technically, when you take a square root, it's to the power of a half. So that's why we do that first. We do it as an exponent. So the square root of 64 is 8 plus 10. 2 times 8 is 16 plus 10 is 26. There's two different ways that you can do this problem. You can take 196 divided by 49 and you get a 4, so the answer is 2. Or the square root of 196 is 14 and the square root of 49 is 7, so I still get a 2. So either way is acceptable. And then finally here we have 3 times the quantity, square root of 144 minus 6, so we have to work in parentheses first. Square root of 144 is 12 minus 6, so that's 3 times 6, which equals 18. Make sure you get all these examples down. And I believe this is the last one. It's an application, computer application. The square computer icon contains 676 pixels. How many pixels tall is an icon? You probably know this. I'm a little old school, so pixels are still new to me, but these are little squares up here. So the little colored dots make up the picture, and the dots are called the pixels. So it says the square contains 676. How many pixels tall? If we look at this as a square, then I can look at that as the area. That's how many little dots cover it. So then I know that my area, which is side squared, equals 676. So the inverse operation of squaring is square rooting. So I know that my side equals, in this case it's going to equal a 26 pixels. And the way that I got the 26 is sort of by, if I wasn't using my calculator, then I would have to just kind of do trial and error. I know my squares on my table up to 20, so then I would try a 21. But 21, I know that 1 times 1 is 1, so this is going to end in a 1, so I know it's not that. If I try 22 squared, that's going to end in a 4, because 2 squared is 4. 23 squared is going to end in a 9. 24 squared does end in a 6. However, if I try this 24 squared, it gives me a 576. So you do have to check it. So it's not that. 25 squared ends in a 5. 26 squared could also end in a 6 because 6 times 6 is 36. And this is the winner. 26 squared is 676. So that's how I know that my answer is 26. Alright, here's your assignment for lesson 3.5. If you want to get started on it, you don't have to. You're going to work on it during class tomorrow. But here it is, page 114 to 115, numbers 1 to 28, 32, 34 to 41, 46, 49, 51, and 52.